Right. So give the question a read.
A car has a mass of 500 kg. The velocity time graph of its journey along a straight road is shown below. Calculate the acceleration during the first 120 seconds. Calculate the force required. Oh, okay.
Oh, we'll do part one time. So we have a velocity time graph. So the gradient will give us acceleration. So we could take 0, 0 as our first point, and which other point could we use?
I'm sorry, right. Following.
This point over here, right?
Yes, sir.
So this point would be 0, comma 0. And what would this point over here be?
120, come on, 20.
Right? So A, acceleration would be equal to the gradient, which would be y2 minus y1. So question, which one do you want to call x1, y1, and which one do you want to call x2, y2?
People 120, y1. I mean x1 and y1.
Right? And I'll do it in parts so nobody gets confused. So the gradient is y2 minus y1 all over x2 minus x1. We're doing this. Right? And we know when you find the gradient, you're going to get E. So that's why I'm putting E there. So y2 is 0 minus y1, which is 20, all over x2. x2 is 0, right? x1 is 120. So we're going to end up with minus 20 over minus 120. So what would that be?
I got 1/6.
Right? 1 over 6. And the units?
M over S squared. Or MS minus 2.
Right. Now in physics, we typically don't leave our answer as a fraction. We typically give our answer to two decimal places. So what's 1 over 6 to two decimal places?
0.117.
Two decimal places.
17. Say it, man.
Yeah, that'd be 0.17, right?
Yes, sir.
Yeah, I thought you said 0.167. Right, so that's the answer there. Great. Calculate the force required to produce this acceleration. So what is the formula for force?
M times E.
M times A. Do we have a particular mass? Did they give us a
Yes, sir.
mass?
Yes, 500 kg.
500 kg. Great, that was the mass. And they want us to figure out the force that would produce this acceleration. So during that journey from 0 to 120 seconds, what was the acceleration?
0.17.
Right, but in the calculation, what do you think I should use? Do you think I should use a fraction?
1/6.
I should use the 1 over 6 because that's the in the exact form. So what's 500 multiplied by 1 over 6?
83.33.
83.33?
Remember that car?
83 point, yeah, 83.33.
Okay, so you have my second question.
Right, 83.33 newtons. Nice. Calculate the distance traveled in 850 seconds. To figure this out, we'll need to find area under the graph. What shape is that?
Attribution.
It's
Oh,
a
trapezium.
trapezium. So just to recap, a trapezium has two parallel sides. That's one long trapezium. You know those sausage dogs?
Oh, yes, sir.
Yeah, this looks like a sausage dog. That must look so funny, yeah? Like,
Yeah.
and they just walk so funny. I feel bad for them. Right. So you would call this length A, and you would call this length B. So the parallel sides are A and B. And then the perpendicular height would be H. And if that's the case, the area would be given by what? You remember the formula?
I have A. I have by A plus B by H.
And you're sure?
Yeah.
Yeah. Okay, good. I'm making sure you're sure. So in the case of this particular question, we need to figure out the parallel lengths. So we need to figure out this length. We need to figure out this length. So it starts from 120 and it finishes at 500. What's the difference between 120 and 500?
380.
380. Okay, what about from here to here?
It'll be 850. Default time.
Right. Let's add a U on there. And what would the height be?
20.
Great. So the area is going to be 1 over 2, 380 plus 850 by 20. All right, so just going to write this note. Area is area under graph. Area under graph is equal to distance traveled. Right? And the area would have been equal to a half. I believe it was 380 plus 120.
Yes. 850.
It was 850. Was it 850? Yeah, it was 850. Yeah, 850. And it multiplies by 20.
Yes, sir.
And that should be equal to the distance traveled. So 380 plus 850, that'll be 1,130.
Um, you sure? Okay.
I mean,
No,
1,230.
1,250. Okay, good. Because I was watching notebook and I was like, oh,
And then you divide that by 2, that'll be 615. And then you multiply 615 by, okay, you get 12,300
yes, sir.
meters, right?
Yes, sir.
Yeah. Yeah, that had to be meters because they said time in seconds and meters per second. Great. So the distance traveled is equal to 12,300 meters. And you're perfectly fine with that.
Yes, sir.
Okay, calculate the average speed now. If I want to figure out the average speed, it's just simply the
Total distance
distance,
over the time.
right? It's just simply the total distance traveled over the total time taken. So the total distance traveled was what?
Um, 12,300.
Right? So what was total time taken?
It was 850.
Right. So that'll be what?
14.47 meters per second.
Perfect. Now, I have a question for you. Would
Okay.
velocity and speed be the same?
No,
No. Which one takes into consideration direction?
velocity.
Velocity. Does speed take into consideration the direction you traveled?
No, sir.
No, it
So,
doesn't.
yeah.
It does not. Okay, word. And Shayna, if I were to ask you displacement, would displacement be total distance you travel, or would it just simply be the distance from the starting point? Displacement.
This is no starting point.
Yeah, it's distance from the starting point. From the starting point. I believe we had discussed that somewhere. Yeah, this is the distance from an object's initial position to its final position. Okay, great.
So we're doing something new after this.
Yes, we are going
Okay.
to look at Newton's three laws of motion,
Okay.
linear momentum and impulse, those things. Fun
All
stuff.
right. Fun. Yay.
So let me just go through all of the formulas for SUVAT since you did this already. I'll tell you where to use it, and we'll
Go to
do.
what? Sorry.
Say that again.
What is it? Sorry.
We are going to look at all of the formulas for SUVAT, right?
SUVAT.
Yeah, like displacement, initial
Oh, yeah.
velocity, final
Sorry. Yeah.
velocity. Yeah, that's SUVAT. That that's just a shorthand version of saying it,
Okay.
right? Right. So you should know what SUVANT means. Let me just do a quick recap. S stands for what? Tell me quick.
Displacement.
All right. Measure displacement in. What do we measure displacement in?
What's that shit? Yeah. Meters per second.
Meters. No, meters. Displacement is
Meter.
just meters.
Sorry.
Right. What is U?
Is the initial velocity.
Right. And what do we measure velocity in?
Meters per second.
Okay. What does V stand for?
Final velocity.
All right. And we measure that in meters per second as well. What is A?
Acceleration.
What do we measure acceleration in?
Meters per second squared.
All right. Meters per second squared. All right. And T?
Time.
Blue.
Seconds.
All right. Let's go through the formulas quickly. First one. V. V is equal to U plus AT. Remember this one?
Yes, sir.
Now, when do we use this?
Who do I
We
remember
use,
this?
all right. So we use this when the final,
All right. Let me find the final velocity.
right, the final velocity when S is not given,
Yes.
right? Let's look at the second one. Second one is S. See if you can finish it, right? So S is equal to UT plus what?
Plus a half AT squared.
Yes. Right. And you think you can figure out when you would use this one? So what is this finding for?
Oh, the displacement.
When given, what's the main thing you need to have for this?
Um, the velocity and acceleration.
Right. And time. Time is the main one there. So you use this formula when you're trying to find displacement with respect to time. Okay. Do you remember any more?
The v squared equals u squared plus um
Two.
2as.
Excellent. And we use this one when no time is given. Okay. And there's two more.
So I think I remember one more. I think the s equals initial velocity plus final velocity over 2 by time.
Hey. Shina, you're real good to remember all of this. That's crazy. Right? Um, four, you use this one when average velocity is useful. When average, see, on the sound of this formula, it's it's look at what it's doing, right? So it's adding the initial and the final, right? And then dividing by two. So this part of the formula finds what?
The average velocity.
Average velocity, and then you multiply the average velocity by time. So you're going to get average displacement. Yeah,
Yes.
right? Right. When average velocity is, and there's one more.
So I don't ever remember getting 4.
All right. Well, this one is just that formula is essentially that formula, but watch. S is equal to VT plus a half AT squared. Yeah,
Okay.
right. And when do you use this one? You use this one when starting with final velocity. Great. So that's all. That's all.
Yes.
Right. Let's do a question now. So let's see. If you're not seeing any questions here, give my year. Give my year. Let me see how good your luck is.
2018.
2000 and what?
18.
2018. Okay, nah, doesn't have anything. 2018. Gimana ya?
2022.
Wait, let me check June.
Okay.
Maybe June might have something. Nope, never mind. Wait. Okay, I'm seeing a question here. So the object attached to the spring in B fell from rest. Okay, so if it fell from rest, what is U?
0.
U is 0. Yeah, U is equal to 0 and it hit the ground after 2 seconds. So they're giving me time. T is equal to 2 seconds. Calculate the velocity of the object on hitting the ground. So they want us to find the what velocity. Ashina?
Okay. Listen.
Yeah. You okay? Like you drop something.
Yeah, something like that. It's okay.
Um, yeah. So I feel like you just dropped plenty things, you know.
I do.
Right. So, um, V, they want us to find for V, right? Because they're giving us the initial velocity, it's at rest. They're giving us the time, 2 seconds of it falling, and they want us to calculate the velocity on it hitting the ground. You okay with that, right? Easy, right?
Yeah.
So they want us to find V. And they're giving us G. Now we know that G is what? What is G? Shina?
Gravity.
So
Sorry.
acceleration due to gravity. So this is acceleration. So they're giving me acceleration. So what formula should I use?
Um, we find velocity. So v squared equals u squared plus a. I mean plus 2 by as.
Okay, let's go back. Let's do a quick, let's go back. What does it say? What does it say for that formula? You use it when
No, oh, we got time.
we got time. So what formula has final velocity, initial velocity, acceleration, and time in it?
The first one.
First one, yes.
Velocity is equal to right.
Right, so V is equal to U plus a t. So my initial velocity is 0, my acceleration as a result of gravity is 10, and my time is 2. So my final velocity is
20.
right. I think you need to practice some more questions like this.
Yes, sir.
Normally you just catch on, but I catch you lacking. So let me come up with some questions. I see you can copy the song in the meantime.
Right, sir.
Okay, so Shina, ChatGPT has generated some nice questions for me.
Okay, so
We will solve it. I don't trust the solutions though, but we'll solve it.
okay.
Right. Great. Question one. A car starts from rest and accelerates uniformly at 2 meters per second squared for 8 seconds. First part, find its final velocity. Find the displacement All right, so Sheena, let me jump straight into it, right? Let's first analyze what the question is giving to us. So when you read it, what can you see they're giving to us?
Initial velocity, acceleration, time.
Right? So they're giving us u, right? They're giving us acceleration. They're giving us time. And they want us to find v. What formula to use?
V equals U plus ET.
Right. You learn from your mistakes.
Yes.
That's just going to be 0 plus 2 by 8. So my final answer is
Oh, sorry, 16
all right, 16 meters per second.
meters per
Right.
second.
Right. So here what? We know what V is now. So we know what V, U, A, and T is. All right. In part B, they want us to find your displacement. So they want us to find for S.
Yes.
So which one do we use to find for S?
Use um what time again? Right, we could use S equals VT plus a half by T squared.
Okay. You want to use that one?
Yes, sir.
Let me
Or we
let
could
me
use S equals
let me
initial
try.
plus final.
Let me try it and let me compare and see what we get. Right? Because there's something important there. So you're saying to use S is equal to U plus V all over 2 by T. Right? But I'm saying that the correct one to use is S is equal to
So
U.
I was saying we will use S equals the UT plus a half AT squared. I said, or you could use the next one after because it was very silent, and I was like, oh,
Well, let me see if we get the same answer. Let's see if we
okay.
get the same answer. So U is 0, V is 16, so 16 over 2. Now it will work out. It will work out. Right, 16
Okay.
over 2, right? And the time is 8. 16 over 2 is 8. 8 by 8 is 64. Let's use the other one. So the other one says U by T, right? So that'll just be 0. You understand why that'll be 0?
Yes, sir.
Okay. Acceleration is 2. Time is 8 squared. So the half and the 2 would cancel off and it's just 8 squared. 8 squared is 64. So yeah, you did good, you good.
Okay. Okay.
I was gonna tell you to use this one because this one has a U, T, A. It have most of the information that we got. But this is fine.
Yes, sir.
Right? So oh right. So that was it for this question. Straightforward.
Yes, sir.
Okay, now we move on to slightly harder question. Oh, you felt the earthquake last night?
No, no, sir. I think
Nah.
I live too far from your point for that.
Okay. Because I up north. I think it was like a
Oh, yes,
more
sir.
north thing. Because you live in south.
Mm-hmm.
Yesterday was an earthquake. Today feel like a tornado. What a win. Well, distance. Part E. Find its acceleration. Right? Part B. Determine the time taken. All right. So Sheena, before we do anything, let's pull aside and look at all the information that was given to us. So they're saying that the vehicle accelerates uniformly from 10 meters per second to 30 meters per second. Yeah,
Yes, sir.
right? So we could safely assume that 10 meters per second was the what?
Initial velocity.
Right? So U is 10 meters per second. And after it's done accelerating, its final velocity is now 30 meters per second.
Yes, sir.
This happens over a distance of 200 meters. All right. Okay, was time given?
No, sir.
So can we use any formulas with time?
No, sir.
No. What formulas will have time in it?
Only one. The b squared equals u squared plus e. I mean plus 2 by as.
Nice. That's it. That's itself.
So the silence is very nerve-wracking.
The silence.
Yes, like when I answer and it's the silence, I was like, oh,
Oh, sometimes I struggle to hear.
oh, like
You're probably be wondering how I does hear Serena, but I don't hear you. Like, you just be hearing Serena by chance. I'm curious.
ah, sometimes, but not that often. Like it is very soft.
Yeah, like I just had to put my ears, my speaker. Telling you. Right. So v squared is equal to u squared plus 2as, right? So we have to substitute here. And most likely we'll have to rearrange, you see that?
Yes, it's a fine isolation.
Okay. Do you want to plug in everything and then make A the subject, or do you want to make A the subject like from the start? What do
I
you
like
want
to
to
make
do?
easy something from the start.
Okay, sure. So tell me what to do.
Just now, so I like to write before I talk. Just now.
All
Yeah.
right.
Right. So give it then.
All right. So tell me what to do.
Right. So you could start by multiplying by the two on both sides to get rid of the two in front of the a.
Multiplying by the two or dividing by the two?
Oh, dividing because it multiply here, but yeah, I was thinking about the next side.
All right. Now, okay, I'll do it your
No,
method.
no,
Then I'll
dividing
do it
by
your,
two. Yes.
yeah, you had said multiply by two.
Ah, sorry.
Yeah. So I was a little confused. But I know you mean divide.
Yes.
So I'll do it your way and I'll do it my way. I think how you're gonna do it is fine, but it might confuse some people. So you want to divide throughout by two. Sure.
So the thing is, with this, like I feel like I do questions where we find acceleration enough where it's just like writing me like E equals v squared minus u squared over 2s. Yeah, but yeah.
Let's say that again.
Honestly, I feel like at this point I've done enough questions where I doesn't even like book how the find the subject, but I just writing the a equals v squared minus u squared over 2s.
Because I can see it so many times.
Yes.
All right. All right, so we have v squared is equal to u squared over 2 plus as. All right. What are we gonna do next? So you want to find for e,
Right. You could move over your u. This might be the wrong one over here. To the next side. Minus u e.
and I could just put our whole thing over 2,
Mm-hmm.
right? And that'll
And
be
then to get rid of the s, you're also dividing by s.
right. So that s gonna go by the 2.
Yes, sir.
Nice. Yeah, this method might confuse a lot of people.
Yes, sir.
So that's what a is. I feel if Jaden looking back at this, they could be like, bro, what is she on about? What? Right. So that's one way you could make 80 subject at the formula. It's perfectly valid.
Okay.
Nothing is wrong with that. Or you could do it like this. So you can move across the u squared. If I move across the u squared, so let me start off with the original thing. So I'll move across the u squared.
Minus u squared.
Right, so that's going to become v squared minus u squared is equal to 2as. And then all I'm going to do is just divide both sides by 2s. And yeah,
Yes.
yeah, like I surprised how come you didn't use this as opposed to
So
that long way.
the thing is, I just get so accustomed to seeing the acceleration that I'm not used to within it. But I mean, your way is the shorter way.
Yeah. So like by now you just see it. You just like see it.
Yeah.
Gotta do. Okay. All right, so that's the formula there. That's the formula there. Cool. And tell me what to put in now. So we know that the final formula is this. This is the final formula. This is what we had to use.
Yes.
And then there was another way to do it. You could have did this substitution, simplify, and then make 80
And
subject.
then maybe, yeah.
So I'll do that as well. I really want, like when somebody look at this, no matter their skill level, they should be able to pick up something at least. But I know that some people don't really like algebra, so this might be hard for them. Even this might be hard for them. But if they see the numbers, it might be easier to work with the numbers. So let me find the answer here. So A would be equal to the 30 squared minus, I think it was 20. Was it? No, it's
Minus
10,
10.
right? And the time was, no, what's the
200.
time?
No,
What's the in
blame
time?
the time.
Right? It was 200 for
That's
the
the time.
displacement,
200.
right? And 30 squared, 900.
900.
900 minus 100 will be 800. 800 over 400 is 2.
Yes,
Just
sir.
confirm if you're getting 2.
Yes, sir.
Okay. All right. Right. So that's one way you could do it, guys. Or you could work it like this. You could say, you could just plug in everything one time from the start. So tell me what to put in, Shana. Because Lord knows my short-term memory is really bad. I think V was 30
We were sitting, yes.
and U was 10.
Yes, sir.
A was no, that wasn't given to us. S was given to us. I think S was 200,
Yes, was 200.
right? 30 squared is 900. 10 squared is 100. And that'll be plus 400A. Move across the 100. So you end up with 900 minus 100. And that's going to be equal to 400A,
And divide by 400, yeah.
right? So you're going to get 800 equal to 400A. Divide both sides by 400. Bam. Right? And you're going to get 2. So I feel like this might be the easiest method for like a beginner.
Yes, so it's easy, but sometimes I like to like see my formula before I start. So it's like, yeah.
Because if you have that formula, you could use that formula anytime, like anywhere throughout the paper.
Yes.
Yeah. You wouldn't have to derive it back again. I understand. Because with this, you get the answer, but you don't really get a formula. Like if you see another question where they're asking you to find for the acceleration alone, you have the formula right here. You just use that. So I
Yes.
understand. Great. All right, part B. Determine the time taken. Right, so we need a formula with time. We have U, V, S, and we just found for A. Right, we just found for A. So A was equal to a question mark before, but now we know what A is.
So we could use V equals U plus AT.
Right. V is equal to U plus AT, right? You want to make T the subject of the formula.
Yes, sir.
All right, let's move across to U. So that'll be V minus U, and that'll be equal to AT. Then you want to find for T, so we divide both sides
Divide
by.
by E.
Yeah. Right, so the final answer for T is V minus U all over A. Right, so that's the formula we're going to use. All right, right. So V was 30,
Yes, sir.
U was 10,
Mm-hmm.
and
It was 2.
wait, yeah, tell me.
It was 2.
Right, A was 2. So we are going to get 20 over 2, which is 10.
Yes, sir.
10 seconds. Nice. If you find this question was a good one,
Yeah, it was nice.
this could come for the exam. It
I
really could.
wish.
It really wouldn't be that hard. Right? Once you remember your formulas, you're good. You're really good.
Yes, sir.
A lot of these formulas you could even derive. I remember I really have a bad memory. So I just used to come up with all these formulas in the exam. I just used to do some quick maths and derive it. Tell you, maths carry me for most of my life. Maths carry
Hmm.
me real hard. Like for chemistry. If somebody asks me why I got a distinction in chemistry, I will say maths. What I used to do,
Yes, sir.
I used to look at the units. So like if I want to get moles and I had moles per kg and I had kg, I could use maths to figure out what moles go be. You would just multiply the mole per kg by the mass and you get moles. I never used
Hmm.
to remember any formulas or anything. I just used to look at the units. Same thing with physics. You could look at the units. You understand what I'm saying?
Yes, yes, sir.
Yeah. Okay. And the other way to do this would have been just to plug in everything from the start, right?
Yes, sir.
So let me do that. All right. So quick movements here. V is 30, U is 10, A is 2. Move across at 10. 30 minus 10 equals to 2t, right? 2t. Well, just simplify this thing one time. 30 minus 10 is 20. 20 is equal to 2t. Divide both sides by 2. Right? T is equal to 20 over 2, which is 10. That's the answer. Great. Right. Do you want to do the last question by itself? It's the hardest one.
Yeah.
Yeah, okay. So far, ChatGPT has not given us any bogus questions. That's great.
Yes, sir.
All right, 3. A truck. I'm feeling lazy to spell accelerates. Uniformly from rest at 2 meters per second squared for 10 seconds and then continues at constant Great. So how much time do you think you need for this question?
So I don't know, not long, I guess.
Okay, I'll give you 5 minutes. Six. It went on six. Finished before that, great.
All right.
This might be
I'll
a
send you
seven
my
mark.
brother.
This might be a 7 mark question in your exam.
Okay. So that's 25 seconds, right?
25 seconds. Wait, which part? Yeah, that's 25
Yeah,
seconds.
right. Okay. The S was looking like an X5.
Serious? I think so. All right. So 1 minute remaining. How things going?
On the second part, and it is going somewhere.
Okay, was this one harder than the last ones?
Let's see. So I'm doing something, and we'll see if it's correct. I don't know.
We will see. My advice is find as much information as you could find for.
Okay.
So the time is up.
Yes.
All right. So Salma, what you have?
Okay. Okay.
I see you got the first question correct.
So was I only correct part for the second thing? Because I was gonna find for the second thing, I was gonna add the foods in the second. I think that's what I was going to do.
No, that is correct.
Okay.
That's correct. Because
Okay. Great.
the you already found the distance from 0 to 10 seconds, right? Right, from 0 to 10 seconds is 100 meters. So now you have to find
Mm-hmm.
the displacement from 10 to 25. So you want some extra time to see if you can figure it out?
Yes, sir.
Okay, good luck. Now,
Thank you.
you want to see how I would part A out?
Yeah.
Because it's slightly different from you, but it would have helped you with the other parts.
Okay.
Now, you did it like this, which is fine, 100% fine. So you said S was equal to UT plus a half AT squared. Now, if we look at the information that's given, let's pull to the side and look at the information that was given. They are telling us that um it starts off at rest, so U is equal to 0 meters per second. The acceleration is 2 meters per second squared, and this takes place for 10 seconds. So T is equal to 10 seconds. So I need you to understand that what they're talking about here is from 0 to 10 seconds. Understand this information here is from 0 to 10 seconds.
Yes, sir.
So we need to figure out. So the only missing part over here is V. Think about it. If something starts accelerating from rest, and we should know what its final velocity is, we should know what velocity it reached after accelerating for that amount of time. Think about it. Shina?
Yes, sir.
So
Sorry.
this truck accelerated from rest for how long?
Um, 10 seconds.
Do we know what the final velocity is?
No.
No. Is that something we could find?
Yes, sir.
Yeah, we could find for that. So keep that in mind. Keep that in mind. Okay, let's move on to the other time period. So the other time period we're going to look at would be from where? So then they said, and then continues at a constant velocity for another 15 seconds. So if they're saying that, that would be what time period? So this was from 0 to 10 seconds. If the truck continues driving for another 15 seconds, the other time period would be from what to what?
From 10 to 15.
No, not 10 to 15. It said,
15 seconds.
right, it said another 15 seconds. So if if this is for 10 seconds and another 15 seconds would carry it to 25 seconds, you sure you understand that?
Mm-hmm.
All right. And they're saying it continues at constant velocity for another 15 seconds. So if it's constant velocity, my question to you is, right, so you understand that the truck would have accelerated. So the graph would look a little something like this. So accelerating, accelerating, stop. For that time period there, it's going at a what?
Constant velocity.
Right. And that's all that happens. So on the graph, let's try to label it. This would be from 0 seconds. What do you think this would be? What time do you think
Oh,
that would be? What time?
okay. Um, 10 seconds.
10 seconds. Lovely. And what time do you think this would be?
25.
Okay, so my question is, if they're telling us what the acceleration is, they're telling us it starts from rest. So this is U. We have E. Is it possible for me to figure out V over there?
Oh, yes, sir.
Yeah. And if I know what that velocity is over there, would I know what this velocity is over here?
Yes, sir. They're constant.
Because it's constant. So, in other words, the velocity for the second half will be the same final velocity as the first part.
Yes, sir.
Right. So, in other words, this V over here will be the same V over here. And well, we know that the time would be what? How much time
10
is
seconds.
10? How much time is 10 to 25?
15 seconds.
Right. So let's answer the question like how you would. So S is equal to UT plus a half AT squared. But you understand this is just the whole question, right?
Yes, sir.
And if we draw a little sketch to visualize it, this would be velocity. Right? This would be time. It starts from rest. So if it starts from rest, 0, 0, it accelerates uniformly. So that's a straight line. And it eventually travels at a constant velocity, right? So this would be 0. This would be some of us.
Oh, sorry. I was working. I was finishing the question.
Okay.
Right.
This,
That was 10, 25.
right. And we,
Something
like,
is. And I was like, hmm?
you get through?
Uh-huh. I'm not sure if I correct, but do something.
All right. Did you, did what I tell you help you out? Like with, I tell you that this velocity here would be the same velocity over here. Like over here now, this velocity here would be the same velocity as over there.
Hmm. Yeah,
It-
because I know, yeah, I know the velocity was constant. Yeah.
Good. Good. So where you go?
For 400.
That's correct.
Okay.
Great. So if we do it like how you did it, U is 0. So this part's gonna be 0. Then it's going to be a half A. A, we know A is 2. The time is 10. Then squared. So half and 2 cancel off. So that's just 100. Great. Or can I work it like this? So Shina, having understood the question, we know that the final velocity is missing for 0 to 10 seconds, hence.
Yes, sir.
So we could find for that. So V is equal to U plus AT. And so that would be equal to 0 plus acceleration. Acceleration is 2. Time is 10. So the final velocity there would have been 20 meters per second, right?
Mm-hmm.
If I know that the final velocity was 20 meters per second, could I use that to figure out the distance traveled?
Yes, sir.
How?
You can only count for 20 seconds.
Say that again.
You could use gs equals u plus v by time over 2.
Say that again.
So the silence.
Come on again. Uh, which formula is that one to use?
Um, s equals u plus v by t over 2. So the silence.
Yeah. Okay, you understand how else we feeling like when I talking and nobody's answer?
Yes.
It really don't feel good.
Yeah, but so I like to like think before I
Okay,
talk, and so what I do into my report without writing it
okay,
first.
okay.
Like, yeah.
Well, it sounds correct, right? Let's see. So S would be equal to U. We know that U is what? What's U?
10.
Nah, U is not 10.
Oh, I was wrong question. Sorry.
Yeah, what's U?
U 0.
U is 0. V is 20 over 2 by time. We know time is 10. 2 into 20 is 10. 10 by 10 is?
Sorry.
It's
Right,
10 by
100.
10. 10 by 10 is?
100.
Yeah, so we get the answer. That's another way you could do it.
All right.
Right. So we could then say S is equal to U plus V all over 2 by T. Right, so that'll be 0 plus 20 all over 2. Right, and we're going to get 100 again. Great. So for part B, so on the graph, right? On the graph, you can understand that I'm gonna put 20 over here. I mean, what's it? Well, yeah, 20. Yeah, we get 20. So I'll put 20 over here. You understand why I'm doing that?
Yes, sir.
So do you think you'd be able to do the question if they said do a sketch of the graph? You think you'd be able to do that?
Yeah.
Okay, nice. This is essentially what you would put. Right? So to figure out part B, all you're going to say, right? So the distance, right? So the distance, it literally just be equal to 20 multiplied by 15. 20 by 15. Right? And which formula did you use
For what?
for part B? But we know
For what?
is literally just V by T.
Yeah, because it's the velocity constant. Yeah. I do 20 by 15.
Right. So distance traveled, right, is just equal to V by T. The velocity was 20 and the time was right? So what do you think about this question?
It was good. It wasn't bad.
Like this is a really nice one.
Yes, sir.
ChatGPT impressed me, boy. I didn't think it like sometimes it'll give you questions that kind of dumb. That's a good one.
Mhm.
Right? So we are done with kinematics, with the study of motion, right? You okay with the graphs and the formulas?
Yeah.
Okay, nice. Let's move on to Newton's three laws of motion. Right. So before Isaac's Newton's law of motion were made known, many people ascribed to Aristotle's laws of motion. Did you know that? Did you know about Aristotle's laws of motion?
No, sir.
Nah? Okay. And he stated that nothing moves unless you push it.
Oh, yeah.
That's so funny, yeah? No, nothing moves unless you push it. Well, obviously, right? An object's speed is proportional to the force applied to it. We learned previously that this is not true because a force is not required to keep an object moving. If there was no friction, an object would keep moving forever. Shayna, think of something in space, right? And you would have watched those videos like with the astronauts in space.
Yes, sir.
I have a question. Like in space, if you apply a force to something and it would just keep on moving.
Yes, sir.
So after the initial application of force, are you applying any more force to keep it moving?
No, sir.
No. So what Aristotle said was wrong. You don't need to constantly be applying a force for something to move. But it makes sense that it make like okay, at that time, that's like real long ago. That's like what, 70s or something? Or like real long ago. You could understand why it sound like it makes sense, right? Because
Yes.
like logically, if you want something to move and you have to apply a force,
Yes, sir.
yeah. So he was thinking that you need to keep on applying a force for something to move, which is a fair argument, but it's not true, right? All right. So Newton's three laws of motion. All right, read the first one from her.
An object at rest remains at rest, while an object in motion remains in motion at a constant velocity, unless an unbalanced force acts upon it.
Right. So an object will remain at rest unless acted upon by an external force. All of that is correct. So the main point here is that you're saying that an object will remain at rest or it will remain in motion unless an external force is acted on it or an unbalanced force. That's fine. So you understand the first law, right?
Yes, sir.
Okay. I presume we don't need to go through the example. It makes sense.
Yes, sir.
All right. The second one. The force on a body is directly proportional to its acceleration. F is equal to m by e. Right? Did you know this one?
Yes, sir.
Okay. And the second one is actually the law of inertia.
Mm-hmm.
Do you know what inertia is?
Yes, we touched this a bit in country.
Okay. So inertia is the amount of force you would need to overcome what?
The change in motion. Well, it's like the resistance in the change in motion.
Yes. Inertia is the ability to resist a change in motion because of its mass.
Okay.
The greater the mass of something, the greater its inertia is going to be because it will be harder to move.
Yes, sir.
So that's why the second rule, or the second law is called the law of inertia, because it says the force on a body is directly proportional to its acceleration. Yeah. And you see there's mass in that, right? So
Yes, sir.
so a trolley with more mass will need a greater force to get it to accelerate at the same rate as a trolley with less mass. That's inertia right there. The third law, every action I think they
So
make a
every
mistake here.
action, every, every,
Yeah, they make a
every
mistake.
action for okay, every action has an equal and opposite reaction force.
Yeah, I guess it's not a mistake, but it sounds weird. Every action force, that sounds real weird. Because I show in
Yes.
school that yeah, just learn it as every action has an equal or opposite reaction. Yeah?
Yes.
Yeah. Scratch this out of here. Right. Shayna, you just fight?
No, sir.
No, it is it is do like what is called this thing? Karate. You ever do karate?
No.
Okay, okay. You're probably wondering you're probably wondering what I just think about you. It's just for example now. Like if you ever throw a punch, you just feel it.
Mm-hmm.
Yeah. You watch anime by chance?
Not really. I've probably watched like three in my life.
Okay, you ever watch The Flash?
Yes.
Okay, do you think super speed would be like a feasible power in real life?
No.
No. If you okay, you know how much force it would take. Like okay, at the point of lift, at the point where he starts running, you know how much force he would need to kick off with to start running at speed? He would destroy he would destroy like a whole city because the force that he's going to exert on the ground is going to be so much that it's going to destroy everything. And then again, he might destroy his leg. Think about it. His leg has to be indestructible. So every force you apply, it needs it's gonna have an equal or opposite reaction, right? And these are some cases. So Sheena, let's try to identify which one of Newton's laws we could apply to these cases. So part one, a rocket or airplane being able to propel itself upward or forward. Which one is this? First, second, or third?
Okay, so if I mean it.
Say that again.
Um, um, it's definitely not two. I'll put a forward. Three?
I would say three as well, right? Because typically with a rocket, and when they're about to lift off, and they would exert a great force downwards, and that would propel them upwards.
Yes.
Right, number two, a child jumping on a trampoline. I would say that's one. I would say that's one on three. That's one on three.
Yes.
Because think about it, when she jumps on a trampoline, she exerts a downwards force, but it's gonna have a opposite reaction and it's gonna push her upwards. Right? So that's three. And number one. Number one, does an object at rest will remain at rest? Actually, no, I scratch that, just three. Right? Because for her to move, she would first need to jump. So she would not remain at rest. So just three. Two is three.
Yes.
Let's check three. Why an astronaut would need to tie themselves to an object while doing repairs in space. Let me see if you can figure out this one.
No one.
One, mm, I would say more two. Remember I said that two is the law of inertia,
Oh yes. The resistant, right.
and in space, you don't really have much friction. Like if you're in space, you would just float about freely. So you need to tie yourself, right? Four. Why a lift
Two.
truck? Yeah, that's two, right? That's inertia. Why seat belts or deployable airbags are necessary in cars? That's three.
Three.
Yeah. Because anytime you have a collision, right? And you just feel that that reaction.
Yes.
When you hit something, when you hit something, the force is in that direction, but you feel the force in the other direction. So um three. Great. So let's move on to linear momentum now. So linear momentum and impulse. So I'd like you to read linear momentum.
Linear momentum is defined as the product of an object's mass and velocity. Momentum is a vector quantity since it has direction. The force that produces a change in momentum of your body is called an impulse.
Please remember that. Please, like sometimes they go ask you where's that impulse, and everybody will remember momentum, but nobody would remember what impulse is.
Okay.
Please remember what impulse is. Impulse is change in momentum.
All right. Change in momentum.
Right. Right. So note the formulas and units for momentum and impulse. Right. So momentum is m by v, mass by velocity.
Yes,
Right.
sir.
And I'm seeing here it could also be force by time. All right.
By time. Okay, sir.
Right. So scenario A, the white ball hits the eight ball, transferring all of its momentum to it and comes to a stop. The eight ball then moves at the same velocity as the white ball. So let's try to understand scenario A. So Shina, in scenario A, this white ball over here, wouldn't it have carried a momentum?
Yes, sir.
Right, it would have a momentum because it has a mass and it's moving at a velocity. When it hits the black ball, what do you think happens to the momentum in the white ball?
It loses momentum.
It loses its momentum. Well, at the way it is still losing. I way is it transfer.
Right.
It
Transfers from
transfers
this
the
momentum.
momentum because there's a law of conservation of linear momentum. It doesn't have loss. It says that in a closed system, the total momentum before collision is equal to the total momentum after collision. So it transfers its momentum to the eight ball.
Right, sir.
So in other words, what's gonna happen here is that, well, we could assume that both of them have the same mass. Both of them have the same mass, right? Otherwise, this wouldn't work. They need to have the same mass for a case like this to happen. You understand why, right? Because if one had a greater mass than the other one, actually, let me think. They never specified. Actually, they did. They said the eight ball then moves at the same velocity as the white ball. So let's think about it carefully, right? So Shina, if an object has a greater mass, what does that mean for its momentum? Will the momentum be less or more?
Target a lot more.
It'll be more. So they said that these two balls, so this ball had a velocity of v1, and then when it hit the eight ball now travels at that same velocity. So if it's traveling at the same velocity, do you think that you would want the balls to have the same mass or a different mass?
Same mass.
A same mass, because if the eight ball was heavier than the white ball, then wouldn't it move, but it would move at a lesser velocity?
Yes, sir.
Yeah. So these two have to be the same mass, right? So the final velocity will be the same. So that's scenario A. Let's read scenario B. The two balls moved at a combined mass. Since the combined mass is exactly twice as large, the resultant velocity will be halved. Does that make sense?
Um, that's not right. I want to reread it.
Okay, reread it.
Yes, sir. It makes sense.
So if in scenario B, instead of the white ball transferring all of its momentum to the eight ball, and the eight ball now is going to move at the same velocity as the white ball previously, in scenario B, what's happening is that when the white ball hits the eight ball, it's going to move as one mass. So both of them are going to move. Understand?
Yes, sir.
If both of them are moving in the same direction, it counts as one mass. And if it counts as one mass, the mass would increase and the velocity would
We have well increased by two. So you'll have it.
in it half it, right? It half it, yeah. Because you understand that the greater the mass is, the smaller the mo well, let me just do some quick maths, right? Just do some quick maths. P P is equal to mv, right? P is equal to mv.
Hmm.
Let's just say we had a mass of 10 and a velocity of 5. The momentum here would be what?
50.
50. Let's just say we had a momentum, what's in? Let me just say we had a mass of 5 and a velocity of 5. What would the momentum be?
75.
Okay, so what happened?
The mass was greater in the first one. Oh,
In,
you're talking about in relation to the question?
wait, so if the mass is greater, it's gonna have a greater momentum. If the mass
Mm-hmm.
is lesser, it's gonna have a lesser momentum.
Yes.
Okay, we know that, right? Now, what's gonna happen, right? Did you do this before in school?
Kinda, but we wasn't supposed to, and we got to an accident. It wasn't like fully.
Okay, well, did you do the law of conservation of linear momentum?
Um, we get the principle of conservation of momentum, and I think that's the only thing we got.
Well, it's the same thing, right? You learn that the momentum before is equal to the momentum after. You learn that?
Yes, total. What was total momentum before collision equals total momentum after collision.
Yes. Right? So I'm gonna come up with a little question here. Let's do that. So let's just say that this mass, wait, what do you want to say the mass of the ball is?
Um, 10.
10. We can say that this has a mass of 10 kg. What do you want its velocity to be? My velocity.
Um, 20. I don't know. 8. Anything.
Okay, cool.
Mhm.
In the first one, we are saying that the black ball has the same mass, right? And after the collision, the mass is the same here. Mass is the same, right? But the velocity is 0. And since that's the case, that would have meant that it would transfer the velocity to the black ball. So the black ball would now be moving at 20 meters per second. And the mass is still 10. So let's see what's going on. So Shayna, before collision for scenario A, before the collision, what was the momentum?
Before collision.
Yeah, so right, so before collision must be equal to after collision. So before collision,
200.
looking at the white ball. So we need to find the momentum. The momentum will be mass times velocity. What's the mass there?
100 kg.
Not 10 kg.
Oh, sorry. I was
You
right.
look at momentum one time. No, that you didn't. No, momentum will be
No, because it
200.
would have been 200.
Yeah, 200. I'm not sure what you do there.
No, I was thinking to say 200 before, and then they was asking me the mass, and so I was watching the screen, and I think I said, I don't know. It's funny. But yeah.
That's okay. So the mass is 10 and the velocity is 20. So 10 by 20 is 200, right?
Yes.
So the momentum before is 200. And what's the momentum after the collision?
Um, 200.
So does that make sense?
Yes.
Right, it does make sense. So for this to happen, both of the balls need to have the same mass. Same mass, right? And this ball started off with a velocity of 20. It transferred that velocity to the black ball, and now it has the same momentum as the white ball. Great. Let's check out this scenario. So let's see what's going to happen here. So Shayna, stay with me, right? So
Yes.
before the collision, what's the momentum?
200.
Right, before is equal to after, it's 200. Now, after the collision, let's see what's happening. So after the collision, both of the balls are moving in the same direction, right? Yeah.
Yes,
Now, if both of them are moving together, what mass will be moving forward?
20 kg.
20 kg. Yes. Excellent. So in this situation, the after momentum will be the mass times the velocity. The mass here is 20, and the velocity, we're calling it V2 in this case. So if I were to find for V2, what would I do?
Um, sorry, read what? Oh, divide.
Mhm. I would divide. Let me just check something.
Wait, the 20 kg will be multiplied by the same velocity, which is 20, so 400, and then you divide by 2.
Wait there. Something not looking right. One second. So the combined mass is 20 kg, right? By velocity. So oh no, it will work out. It will work out. Yeah, it will work out. So we have 200 is equal to 20 times V2. So you understand everything we have so far?
Yes, sir.
So we want to find for V2, which is its final velocity. So we'd have to divide both sides by
20.
what's 200 divided by 20?
So, wait, sorry.
200 divided by 20.
It was 10, right?
10.
Come on, 10.
Does by us putting in these figures, does it show that scenario B is correct? It says that since the combined mass is exactly twice as large, the resultant velocity will be half. Did we see this?
Yes, sir.
Let's observe. What was the initial velocity?
20.
What's the final velocity now?
10.
Yeah. What was the initial mass?
10.
What was the final mass?
20.
Right. So I think you understand the concept, right?
Yes, I do.
Nice. And you understand that according to inertia, the greater the mass, the the lesser the speed would be. Like the speed would be less.
Yes, sir.
Okay, good. And the reason for that is because we conserve in momentum. We are conserving momentum. Okay. Right? So the law of conservation of linear momentum states that in a closed system, the total momentum before collision is equal to the total momentum after the collision. Right? So let's try this question and see if we could figure it out. I think we could figure this out. Um, I like to think that this particular topic, you could figure it out. Like if you forget it in the exam, trust me, you could figure it out.
Okay.
But once you remember the formula, once you remember that momentum is P is equal to M by V, you should be fine. Right. So before we start, could you just remind me what the law of conservation of momentum says?
That the momentum before is equal to momentum after.
Right? The total momentum before collision before is equal. Right. And what do we call this?
Cool what? Sorry.
This is the
The
principle of conservation,
principle of conservation of momentum.
right, of linear momentum. acceleration. Great. So let's apply it in this particular question. So Shayna, before collision, this one will be before collision, correct?
Yes.
Right, so this is before. This is after. So let's observe some things. If we're looking at before the collision, let's pull aside and put on all the information we have. So this is before. Could you tell me what? Right. So by the way, I would refer to if I'm talking about the initial velocity, talking about the
Mhm.
velocity before, I'd say v1.
Yes, sir. And
So
obviously,
v1 would be equal to 3 meters per second, right? The mass of the first one, okay, the mass of this cart here was just 4 kg. Okay, great. So is it possible for me to figure out what the momentum is before?
yes.
That would be straightforward, right? Let's look at after now. Let's see the information that was provided. If you observe in the diagram, what happens after the collision?
The mass is equal as 1 to combined.
The mass combines, and they want us to figure out for V2, correct?
Yes, sir.
Right. So the new mass would be equal to 4 plus 6. So that'll be equal to 10 kg. So let's answer this question quickly. So momentum before is equal to momentum after. So it's going to be, just remember that P is equal to mass times velocity. So momentum P is equal to mass M. Great. So the momentum before is just going to be 3 by 4, and that's going to be equal to the mass, which is
12.
10 by V2.
Um,
So what's 3 by 4?
12.
And that's going to be equal to 10 V2. What would I find for V2?
You divide on both sides by 10.
This is looking like a capital V. I don't want that to look like a capital V. Right, so V2 would be equal to 12 over 10, which would be,
1.2
yeah, 1.2. In units.
meters per second.
Great. You okay with that?
Yeah.
Okay, nice. Right. Yeah, and well, same thing for the mass, right? Just call this M1 or call this M2. Yeah, forget to put that. Okay, great. So easy so far, yeah?
Yes, sir.
So, so guys, if you are looking at this, the principle of conservation of linear momentum says that the momentum before needs to be equal to the momentum after the collision. The formula that you're going to use for momentum is mass times velocity. So in this diagram, we had a cart for mass 4 kg moving at a velocity of 3 meters per second. So V1 would be 3 meters per second, M1 would be 4 kg. So the momentum before would just be the mass times the velocity, which is 3 by 4. The momentum after, we do not know what the final velocity is, So V2 is equal to a question mark. However, the mass after the collision is 4 plus 6 because now it's moving as one body, right? So 10 by V2. So to find for V2, I just divide both sides by 10 and I get 1.2. Great. Let's do our question. Right, so Shina, you want to attempt this question by yourself or do it together?
By myself. But just one thing, so when I was talking before, they say moments could be calculated as m times v or f times t, and it's like impulse equals f times t.
Yeah, impulse is
Sounds
equal to
like
F times
okay,
T.
great. I want to try it myself.
Wait, let me just verify that. I believe they make a mistake. They're not supposed to be the same symbol. Let me just verify that. Yeah, they make a mistake.
So it's not f times t because we learned it as like momentum, sorry, equals mass times velocity, and then impulse equals force times time.
No, I'm not saying that this wrong. This is correct. Force by time
Oh,
is
okay.
correct. But the symbol is J. J is the symbol for impulse. That's what I'm seeing here.
All right.
What did you all learn the symbol to be?
I don't know if we learned that symbol. I think we just wrote out impulse times f equals f times t.
Yeah, that's what it's supposed to be because before um these notes had P is equal to mv and P is equal to F by T, but that's wrong. Momentum is not F by T. That's impulse.
All right, true. Thank you.
So let me just put it on over here. Give me a moment. I'm just gonna fix this up. Right, and then impulse. Cool. These are the formulas you need to remember. Right. Cool. Right, so let me just verify that. So G is G.
So for the second part, impulse is like the change in momentum. So
Yeah.
the so one and two will be the answer.
Say that
That's
again.
one and two. I'll say isn't impulse change in momentum. So one and two will be the same answer.
So one and two will be the same answer for this question.
That's one and two. Uh-huh.
Yeah, it's supposed to be the same answer.
Okay. So are the units and it's a full momentum what the impulse.
Impulse, I'm gonna tell you what the units could be. So you see that the formula is F by T.
Mm-hmm.
What do we measure force in?
Oh, F newtons.
And time?
S seconds.
Newtons and
Okay. So I already sent your answer, but I'll pay you.
all right. Right. Let me see what we have here. Okay, you need to put units for your work, huh?
So I did send it before I asked. That's why.
Oh, okay, okay. All right. Well, let's answer the question. Right. So a footballer's boot is in contact with a ball for 0.05 seconds. So that's the time. They're giving us time. T is equal to 0.05 seconds. The force on the ball is 180 newtons. So they're giving us force. Okay. And the ball leaves his foot at 20 meters per second. Right? So they're giving us what there? The velocity, right?
Yes.
Nice. Impulse. Impulse G is equal to F by T. So it's going to be F. F is 180. By time is 0.05. And you should get 9. Right? Just confirm that again.
Okay.
9. Yeah. Right? So that just be 9 Newton seconds. You okay with that?
Yes, sir.
All right. Cool. Now for part 2, it's the same answer, but the units is going to be different. We typically wouldn't write it as Newton seconds. Let me show you what I mean. So Shana, let's check out something real fast. So question, what's force equal to?
Newtons. What was the unit?
Yeah,
Or like what exactly?
what's the units of force? Well, we know it's newtons, right? We know it's newtons. But what's its SI units? So the formula for force is mass times acceleration, right?
Mm-hmm.
So what is the unit for mass?
Kg.
What's the unit for acceleration?
Um, meter per second. Squared. Squared.
So ms minus 2. Mm-hmm. So that's the SI units for force, right?
Mm-hmm.
Okay. So when I needed to understand something, right? Impulse is another formula for impulse, right? Impulse is just change in momentum. Impulse is just change in momentum over time. That's literally what it is, right? What is
Yes,
the
sir.
unit? Do you know what the units for momentum are?
Is it will be kg by meters per second. So
So it's mass times
km
velocity. It's mass
mass.
times
Mhm.
velocity. Shina?
Yes, sir.
Yeah, so it's mass times velocity. So the mass is kg, and what do we measure velocity in?
Meters per second.
Right, so ms minus 1 or just m slash s. Yeah,
Mm-hmm.
right? And when you divide that by s, that's how you get kg m s squared. I feel like I confused you a bit there.
Yes, okay. I'm following.
You following?
Mm-hmm.
Okay. And it should work out. Let me just check this. So F is equal to m by a, right? That's kg ms minus 2. Impulse is just changing momentum over time. So momentum is just kgm slash s over s, right? Okay, that's weird.
So you can slightly because I was told the
Wait,
unit was kg m over s or kg m s minus one.
that's the units.
Okay.
But wait, so the answer, I'm just write the answer for part two, right? So the ball's change in momentum, simply for the change in momentum, would just simply be 9 kg meter per second,
Yes.
right? Because that's how much the momentum would have changed by. And the units of momentum is
Kg meter per second.
right. But I'm trying to prove something here. I'm trying to show you why, I'm trying to show you how we get Newton seconds. Trying to show you that.
Okay.
See if I could figure it out. So the change in momentum over time is equal to impulse. So the change in momentum, the units for that, for momentum, would just simply be kg m s minus 1 all over time.
Mm-hmm.
Okay. And so that would work out to be kg ms minus 2. Now, kg ms minus 2 is the same thing as force.
Yes, sir.
Yeah, this is the same thing as force. But then in the formula, it has force by time.
Mm-hmm.
That's weird. I will check back this. I'm sure there's some other derivation, but I will check back that. Essentially,
All right.
what we're supposed to end up with, we're supposed to end up with force by time, but we're only ending up with force. So that's weird.
Mm. Okay, sir.
All right. So let's continue. So you understand part one and part two, right?
Yes, sir.
Okay, part three, the mass of the ball. Mass of the ball. How would we find mass? Using what formula? F is equal to,
More information.
all right. Let me see where you got. You got
I didn't
0.45 kg.
Uh-huh.
Okay, you use the
The
impulse
formula
formula.
for the formula for moments.
Okay, sure. So P is equal to mv. P is equal to mv, right? And we want to find for mass, so mass would be equal to P over V.
Yes.
P over V. What was the change in the momentum?
9,
9. What's the velocity?
20.
Right? A 9 over 20 should give it a 0.45, right?
Yes, sir.
Cool. Let's try using F is equal to ma. Let's see what's gonna happen. M is equal to F over A. But the problem might be that we don't have acceleration.
Yes, sir.
Yeah, to have acceleration. Yeah. So we can't use that formula. All right. So the next class, we'll look at some more problems involving linear momentum and collision. Would you like some past paper questions on this homework?
Yes, sir.
Yeah, I will send that. All right.
Okay.
But you feel a little more confident with the SUVAT equations?
Oh, yes, sir.
Okay, good. All right. So I'll see you next class. Well, I'll see you next time I see you is Friday. No, Tuesday. Tuesday.
Yes, sir. So it's a big one.
All right. Well, you have a blessed day. You take care.
You too,
Bye.
sir. Bye.